Hey everybody, good morning. This is Varun Divadkar, and I am here to walk you through this interesting presentation on machine learning and applications, in which we would be studying the concept of machine learning, what machine learning exactly is, and how it distinguishes itself from traditional rules-based programming. Thereafter, we will be looking at certain variations of machine learning, the types of machine learning, and eventually the paradigm of deep learning, and then small applications from machine learning and the deep learning universe, right? So let's begin this presentation with a simple example on the whiteboard where I would be showing you what machine learning exactly is, and you will be promptly able to get the concept at the moment. So let me choose OneNote and begin. So let's say, for example, I give you an equation that says y equals 2x, right? So here, you know x, and then you know the relationship of y with x, right? So this is a parametric equation, right? Because these two parameters are related. Now, let's have some values. Let me ask you, if I want to have a plot of x versus y, and I say this is x and this is y. So suppose x takes the value of 1, and I ask you what value would y take in this case. So you immediately would say it's going to be 2 into 1, which is 2, right? Because you know that y is twice of x. Similarly, if I say x is 3, you know that y is going to be 3 into 2 is 6. If x is 5, you would promptly say y is 5 into 2, that is 10, right? Similarly, if I take another unknown value, arbitrary, and say x is 30, then you'd say y is 30 into 2 is 60, so on and so forth. So here, if I give you any value of x, you know its related value, y, from this equation. So in this case, you already know the relationship between x and y, and then you are using it to find out unknown values of y with given values of x. So this is called as rules-based programming, right? Now, if you have got rules-based programming clear in your mind, let us contrast this with another situation. Suppose I give you a table that looks like this, where you have some predetermined values of x and y. So like if x is 3, y is 9, x is 2, y is 6, x is 10, y is 30, x is 4, y is 12. And then I ask you the question, suppose x is 8, what would y be? Now, in this case, you do not know the relationship between x and y, right? But if I ask you, use this table to find out the relationship between x and y, and based on this knowledge, you would have to tell me the value of y for this given value of x, right? So what would you do? As a human being, what you would do is you would just try to find out some relationship between these two numbers by observation. So here you see that 9 is thrice of 3, 6 is thrice of 2, 30 is thrice of 10, and 12 is thrice of 4. So you come to know that y is thrice of x, right? So that's the relationship between x and y. So now using this relationship, if you put in the value of x as 8 and y is 8 into 3, which is 24. There you go. You've just found out the unknown value of y based on an arbitrary value of x, but then you got this equation using the knowledge gained from this table. There you go. This is machine learning, right? So how is that? Your machine learns values from this data table, and this is called as the data set. So what a machine learning algorithm does is it looks at the data set, looks at the values from the data set, and it tries to find out a relationship between the input and the output, right? So this simple example which we took right here comes under the paradigm of regression, where you are trying to find out the relationship between two variables. So here, the first variable was x and the second variable was y, right? And the way these two variables are related was y equals 3x. And you found this out by observing the values of x and y from the input dataset table. Now, this was a very simple way of doing things, but in reality, regression might not be that easy. You have to devise a method for finding out the relationship because you might have many x values. Like it might be like y equals to ax1 plus bx2 plus cx3 plus d, such a complex equation, and then you might have to find out the values of A, B, C, and D. And this cannot be done just by observation, and there are various ways to do that. One of them is like the sum of the squared residuals, right? Where you basically find out the difference between the actual y and the predicted y based on your equation, and then you find out the value of the minimum sum of the squared residuals, which determines the best fit line, right? So this is regression. Another problem in machine learning can be classification, where what you try to do is you're correctly trying to classify objects into their respective categories. Like, for example, you're trying to identify a dog as a dog, maybe, and there's an image of a dog, and you're trying to identify that as a dog. There's an image of a cat, and you're trying to identify that as a cat. So here, what exactly happens is that you feed your model thousands of such rows of different images, and then you also feed it with labels, whether it's a cat or a dog or a dog or a cat, right? And from this, the machine automatically tries to learn whether if you see this kind of an image, you have to classify that as a cat. And if you see this kind of an image, you have to classify that as a dog, right? So this is called as a classification algorithm, right? So we spoke about regression and classification. Well, these two algorithms come under the category of supervised learning. Why supervised? Because there's a supervision on the data set, supervision with labels. You are classifying the elements in the data set beforehand using labels, whether if something looks like this, it's a cat. If something looks like this, it's a dog. If something looks like that, then it's some other animal. You are already assigning these labels, so the algorithm has some guidance or some framework to learn from the input data, and that's why it's called as a supervised. But then contrast this with another problem where you have just given like chunks of data points like this, and you do not know which category each of these data points fits into. This one, this one, this one, this one, and this one, all of them. And just like that, you're supposed to now classify them into their own categories. Like if these elements look grouped together, you have to classify them into one category, this one into another category, this one into another category. Such a problem is called as an unsupervised learning problem, right? So here there is no supervision at all, and that's why it's unsupervised. And one of the examples of this algorithm is k-means clustering, right? Uh, that's a popular unsupervised learning algorithm, right? So let's go back to the presentation. So this is what it is. So that's exactly how machines are taught to learn, where you feed the algorithm with multiple such rows of data with their corresponding labels, right? And from here, the machine learns to unravel what's going to happen with a new set of data, right? That's machine learning. And as we just discussed, the typical algorithms are like regression, the one that you see on the extreme left, classification, the one that you see at the bottom, and then clustering, the one that you see on the right. Is it? Now, typically, in machine learning, what you do is when the data set is small in number, you use machine learning, but then eventually what's bound to happen is that you want to unravel complex patterns from your data. That's where deep learning comes into the picture, right? So deep learning, basically the name deep comes from the fact that you use deep neural networks to unravel patterns in data, where if you look at this screen, you have neural networks that look like this, right? This is called as the input layer where, say, if you have an image of a dog, right? Then each pixel in that image might represent one data point over here. Now, just for representational purposes, this might be just 5 circles, but then in reality, this can mean even thousands or millions of circles, right? So each pixel represents these points. And then we have a hidden layer in between. This hidden layer basically processes the values from the input layer, where every data point has a weight associated with that. So if you look at this connection here, this is W1, W2, W3. So you're basically multiplying the value of the input with its respective weight and then taking a weighted product of the respective inputs and then adding another term called as a bias, right? This is a constant term. And then you're trying to find out, similarly, for every other point in the hidden layer, you have such connections. And then these connections again have their own connections here. This goes on and on as long as the layers do not get over. And then finally, you have the output layer over here. So here, it can be a binary classification, either as a dog or no dog, right? Two outputs. So what this neural network tries to do is it tries to learn the best values of W1, W2, W3 that can match this output of a dog or a no dog, right? Similarly, for other images of a cat or any other fruit like an apple or orange, it tries to do the same thing, isn't it? So that's deep learning for you in simplicity, right? And typical applications of machine learning and deep learning can be diverse, right? Like ranging from image recognition. Let me erase this annotation. So typical applications can be like image recognition, and then if we delve deeper into today's world of deep learning, you can have speech recognition, you can have speech to text, And then in the recent past, what has happened is the transformer architecture has revolutionized this paradigm of deep learning, where speech translation, and then as of the moment, you have large language models that have taken over the world by storm. You have your GPT, you have your Google Gemini, you have your Llama, right? So these models have revolutionized the landscape of deep learning, where now AI agents are basically coming into picture. So AI agents and agentic AI is the trend of today, where tasks can be thought about, they can be planned, and they can be executed all by a single agent based on the kind of architecture that you build. So this is in short about the discussion on machine learning, AI, neural networks, and its applications. I hope you like this discussion. Please let me know if you have any questions, and thank you so much.